Okay, we're going to continue reviewing some of the things in Chapter 3 here in just a little bit more depth than we did in CPDM 151. There are several folders that you'll be using throughout this course. We might not use them all. Matter of fact, I know we won't use them all, but these are some folders that ASP.NET knows about and does some things intrinsically behind the scenes for you. One is the app code. This is where you're going to place all your class files, any WSDL files, or any type data sets. Anything that's in here is available to all your pages in your solution. The nice thing about it is that it automatically compiles the class files. It automatically creates XML web service proxy class for any WSDL files, and it automatically creates a types data set for any of the XSD files that are there. And these files are instantly available to your page and will show in IntelliSense as well once they're there. So that's a folder we will be using and you will be using throughout this course, especially for class files. The app data holds data utilized by the application. It can contain Microsoft SQL Server Express, Microsoft Access, XML files, and a number of other files. This is where you use your data. The user account that is associated or utilized by the application has read-write access to any of the files that are in the app data. We'll be using that a little bit later in the course as well. App themes, which you should be familiar with. This is a place to store any of the skin files, any cascading style sheet files, image files that are used in a theme. And it just ensures that all the pages are able to take advantage of the theme and its elements. The app global resources, you can add assembly resource files to .asax. Again, they are dynamically compiled and made part of the solution and immediately available to all the pages. If you don't want to make something global and you have something for a specific page, you could use the app local resources, and these would be resources for a single ASPX page. So let's just say we wanted a resource page for the default. It would hold a page like default.aspx.resx. There's a couple other different file types that could be there as well. The app web references, this allows automatic access to the remote web services referenced in your application. The app browser holds browser files. There are XML files that are used to identify the browser making requests to the application and to understand the capabilities of the browser. You can see these, and they're located again in the Windows folder, Microsoft.NET, Framework, 4.0, Config, and then Browsers. So you can see all these. We've got Safari, Opera, iPhone, IE Mobile, IE, a generic one, Gateway, Firefox, default browser, Chrome, BlackBerry, and these are XML files, as I said, and it includes capabilities and things like that. So it includes information about it. Now, if for some chance you wanted to make changes to this, you would want to copy the file you're going to make changes to, move that file into the app browsers folder, and then open it from there and make whatever changes you want there. Do not go making those changes to the original files in the framework. The compilation of your website. Still background and show you a couple things here. So what happens when you make a request? When the browser makes a request, it's passed to the ASP.NET parser that creates a class file in the language of the page. It is then passed to the ASP parser that's based on the file's extension, the ASPX. That's what triggers everything to be there, because the server actually then realizes that it is meant for special handling and processing. So the ASP engine then gets the ASPX file, uses the code behind class, generates a page class where actually compiling it. It instantiates, processes, and then renders a page class that is sent back as HTML as the response back to the browser. Now keep in mind that this is done the first time that it is requested. It is only done once after any change. So if we were to change this, make any changes to our site, we would have to recompile this again. So we would go through this process again. If no changes have been made, the next person that makes the request, or any other subsequent ones, no longer have to go through the long entailed process of combining the ASP with the code behind and generating all this. It just goes straight to the page class that's been generated before and immediately sends back the HTML to the call. Now, the problem that you run into with this, and this is a problem with especially with .NET Nuke, where you've got capabilities on the web of changing it. You have a content manager, so to speak, that's behind the scenes allowing all these changes. The problem becomes, especially on large sites, that when it goes through this process, sometimes these pages take a while to compile. And I'm not talking about minutes, but long enough that the user's going, well, why is this going so slow? Especially if they're on a dial-up or something. So it slows down the process of watching this, or actually being able to see the page, because again, every time a change is made, it has to recompile itself. So there are a couple options for pre-compiling, and these are done through the command line. You have an in-place pre-compilation, which uses actually both of them use, both methods I'm going to show you use the ASP.NET _compiler.exe tool. And you can get to that tool very easily. Windows, you go to All Programs, find your Microsoft Visual Studio 2010, go to Visual Studio Tools, and second from the bottom here would be the Visual Studio command prompt. That's the shortest and fastest way of getting there. Another way of doing that would be to type all that in and actually drill down using the command line until you got to that folder. But this is a shortcut. It gets you there right away, and you don't have to remember all the numbers that go with the version 4 that come after it. So once you have that tool up, then you would enter a line like this: ASP.NET _compiler -p quote C. This is the actual path, the physical path of it, and -v is another command, and that would be the virtual path, and here we have none. This then would actually compile every single page, and it would also instantaneously tell you if it finds any runtime errors. Remember, some of those are some of the hardest ones to find, but if it finds any runtime errors, you would be notified. On the bottom here then, and in the book on page 34, you'll find all the other commands that you could possibly use for this. So that's one way of pre-compiling it. And I normally do this on my local IIS and then copy the files up. The other way is pre-compilation for deployment. This actually enables you to compile your application down to some DLLs and then allow you to deploy that to customers, partners, or even to yourself somewhere else where you can use it in another place. There's a minimal number of steps required. You simply need to move around the DLL and some placeholder files for the site to work, and then copy everything back up to the production server and get it to work. So again, it takes the V, which is the virtual directory, the application name, -P, the physical location, and the target. The target is a folder that you have to configure or have to create prior to doing this. It won't create the folder for you, so you have to pre-create that. So if we had, for example, a Thomas Reuters, then I would have the virtual path, which would just be /Thomas Reuters, the physical address or physical path to it, and then all my files, all the results are going to go to C-Rocks. So after compiling the application, you would simply go to the folder that you designated. In this case, it was C-Rocks, to see the output. The bin folder would actually contain the code.dll file. That file then would have all the page code, all the code in it. Because it's a DLL file, it obfuscates the contents. So it makes it basically unreadable for anybody else to look at. From there, you just move those files to another server using FTP or Windows Explorer, and then you can run the entire web application from those files. When you have another update to the application, you go through the same process and then simply provide a new set of compiled files to the server like we did before, or like you did this time. Now, this does not compile HTML, XML, XSD, web config files, or text files, and there's not much you can do about this. However, in the case of HTML and text files, you could change those extensions to ASPX. In those cases, then they would be compiled into the code DLL with all the other pages, but other than that, there's not much you can do. So those are two ways of pre-compiling your pages so that when changes are made, so the user doesn't have to go through the time it takes for them to wait for the new page to be compiled. And again, that's only done the first time through. But still, you don't want your users sitting there and waiting. Build providers. As you review various ASP.NET folders, note that one of the more interesting folders is the app code folder. You can simply drop code files, XSD files, and even WSDL files directly into the folder for automatic compilation. Which file types are compiled in the app code folder? Well, as with most things in ASP.NET, that's determined through settings applied in the configuration file. And if you remember the root web config file we looked at in a previous video, in that same file you will see a section of build providers. This section contains a list of build providers that could be used by two entities in your development cycle. The build provider is first used during development when you are building your solution in Visual Studio 2012. For instance, placing a WSDL file in the app code folder during development in Visual Studio causes the IDE to give you automatic access to the dynamically compiled proxy class that comes from this WSDL file. The other entity that uses the build providers is ASP.NET itself. Simply dragging and dropping a WSDL file in the app code folder of the deployed application automatically gives the ASP.NET application access to the created proxy class. A build provider is simply a class that inherits from system.web.compilation.buildProvider, the section we just looked at in the web config. The build provider section in the web config file allows you to list the build provider classes that will be utilized. For example, the one for the WSDL file that I keep referencing here is right here. Microsoft provides a set number of build providers out of the box for you to use. Just by looking at the names of some of these providers, you can pretty much understand what they're about. Two providers that we're going to cover are Force Copy Build Provider and Ignore File Build Provider, both of which are included in the default list of providers. The Force Copy Build Provider copies only those files for deployment that use the defined extension. Again, if we look at this, the actual build providers that we have here, and we look at one for force copy build provider, it's only going to deal with the JavaScript files in this particular case. In addition to the force copy build provider, you should also be aware of the ignore file build provider class. This provider causes the defined file type to be ignored in the deployment or compilation process. That means that any file type defined with ignore file builder provider is simply ignored. Visual Studio will not copy, compile, or deploy any file of that type. Again, looking at this with some of the ignore, there's actual several of them here that you can see. The refresh, exclude, license for a license type file, LICX. So those would actually be ignored during compilation. If you were using a Visio diagram and had that included in your application or project, you would add that in here as well so that that's not compiled. In addition to using the predefined build providers out of the box, you can also take this build provider one step further and construct your own custom build providers to use with your applications. The book goes into detail on how you could actually do that. The global ASAX file. This is used by the application to hold application level events, objects, and variables. It's all accessible throughout the application. Basically takes care of session as well as application events. There could only be one global ASAX, and it must be in the root directory. It can contain directives such as @application, @assembly, and @import, as well as methods application start, session start, application begin request, application authenticate request, application error, session end, and application end. There are many others in there as well, but those are the basics.